Hi, my student told me about this integral. Apparently, it's a problem in the integration B at the Berkeley Math Tournament at UC Berkeley. So in this video, I'll be solving this. This is a great integration B kind of question because it's tricky. There's a trap in it. The trap consists of this. You look at the integral and you see that this integral we can do. We know what the integral of that is. That's arctangent. You look at this and say, hey, I know what the derivative of that is. So you're thinking, maybe I should do integration by parts. This is u and this is dv, right? That's what we do with integration by parts, right? We look for some factor where we know the derivative of, and we look for the remaining factor that we know the integral of, and then we do integration by parts. Except that that would get you to a dead end. Okay? Because remember, we don't just look for the u and the dv, we look for the kind of u where after we take the derivative is simpler, and the kind of dv so that after we take the integral, it's either simpler or at least equally complicated. It doesn't get more complicated. Whereas for this one, if you take the derivative of u, yes, it gets simpler because you get u out of the inverse trig function. But you take the integral of dv, it brings you back into the inverse trig functions. And that sounds like a bad idea. So yeah, that's a trap. Whereas in a competition, if people give you a definite integral, chances are they look for you to do something with that definite integral as is, with the limits and everything, and not just like a homework problem in calculus where you do the indefinite integral and you plug in the limits. No. They want you to do something about this integral the way it is shown. All right, so let's strategize. We have an integral from -1 to 1 of stuff. The limits of the integral are from -1 to 1, symmetric across 0. So it's sort of a hint that says that maybe you should think about the parity of the function. Because if you had a function that is an odd function, is symmetric across the point 0, 0, and you take the integral from -1 to 1, the integral of that odd function would be 0, because anything that's positive on one side here will cancel out with the symmetric negative on the other side. Anything that's negative on one side will be canceling out with the symmetric positive on the other side, so the whole thing is equal to 0. So you're going to look at this function, and you see that the denominator is even. So if the numerator is odd, then the whole thing is odd. Well, is the numerator odd? What is the graph of arccos? The graph of cosine looks like this. And if I want the graph of arccos, I take the mirror image across the 45-degree line, then I end up with something like this. So that's the graph of arccos. This is 1, 0, -1, pi, and 0, pi over 2. So that's the graph of arccos. It's not odd. The whole integral is not going to be 0. Arccos is not an odd function, but now that I look at the graph, it's kind of odd. An odd function is symmetric across the origin 0, 0. This function is symmetric, but across that point, 0, pi over 2. So if I can bring in the function that just like our cosine, but symmetric across that other point there, the origin there. If I can bring in this function, then the integral would be 0, because that one is an odd function. Well, what's that one? That one is just the arc cosine function is shifted down. by a distance of pi over 2. So I want that. I want the function arccos minus pi over 2. And how do I get this function? I subtract pi over 2. So if I subtract pi over 2 and add pi over 2, then the part about arccos minus pi over 2, that part, the integral will be 0. The remaining part, pi over 2 over 1 plus x squared. Well, dx over 1 plus x squared is just a derivative of arctangent. So I know how to do that integral. So yeah, that's my strategy. I know my strategy now. I can now do this integral by first subtracting pi over 2 and then add pi over 2. Same denominator, negative 1 to 1. This denominator is even. This numerator is odd. Then the whole thing is odd, and the first integral is equal to 0. Now the second integral, I factor out the pi over 2. The dx over 1 plus x squared, the integral of it is arctangent from negative 1 to 1. So that's equal to pi over 2 times. Arctangent of 1 is pi over 4. Arctangent of negative 1 is negative pi over 4. So that's another pi over 2 in parentheses there, times the pi over 2 on the outside. I get pi squared over 4. So pi squared over 4 is the final answer. Well, that was fun. I hope you liked it too. Like, share, and subscribe for more contents. Any questions or comments, put it in the comments section below. And thanks for watching. Bye.